My name is Joris Peels, and this is another episode of 3D Printing News Unpeeled. And today we take you to the top additive manufacturing and 3D printing news of the day, and together with 3dprint.com. And well, we've got 5 news items for you today. The first one is from Duffy London and Sandhelden, and it's 3D printing a Dune coffee table. This Dune coffee table is not inspired by the movie Dune. It's inspired by sand dunes, and the idea is to take the kind of wavy forms of sand dunes and take that into a coffee table. It's made by Christopher Duffy of Duffy London, and it was printed by Sandhelden. What's I think the exciting part for us is that what they're using here is a sand 3D printing technology, like the Binajet sand process we're seeing from VoxelJet, or X1's process, which is similar. And that's traditionally used to make casting cores, and it's an intermediate. It's something we use and then discard to get metal parts. And Sandhelden have turned these things into end-use parts, such as this kind of furniture item. And the sand is also a kind of new material for a lot of designers. And I'm not sure if it's suited for this kind of application. They, of course, apply some reinforcement and other things as well. But I think it's very eminently suitable for the next application, which is for Sandhelm also. It helps designers and companies print sand objects as end-use objects, but it also makes parts like this, which is a kind of end-use sink. So, we often kind of like class certain processes as intermediate processes or end-use processes capable of making end-use parts. But what Sandhelm have done is kind of created this nifty niche for themselves in creating using a quite noble material, quite well-known material, and also at the same time kind of new material. Not a lot of designers work with sand, as they were like kids on a beach. So I think that's a really interesting reappropriation of this material and reuse of this material and the process in a completely new way. Number 4 news is that Caracol has launched Heron AM. Caracol is an Italian large format polymer 3D printing company that essentially makes its own software and hardware in-house based on 6-axis robot arms, and it makes essentially the extruders and the software to 3D print as a service. Right now, the company's announced that it's upgraded its existing 3D printers it uses to make production parts into Heron level systems. And the Heron is a new system by them, and they have 7 traditional ones. And one of these is actually on as a 7th axis, if you will, is actually on a rail. So it's a 6-axis robot with the pellet extruder on it, and it's on a rail. And this is capable of making 15-meter large parts. The company also has in-house CNC and has so far done 150 projects and 29,000 hours of printing on its new Heron type system. The key advantage the company says is in the lightweight extruder. Now, of course, there's only so much weight the robot arm is designed to take on, so an increased payload, of course, could make it move faster and could be better for the robot, and could also make it maybe take more material or be able to feed more material into it as well. So it's quite a significant advancement. The pellet extruder can take materials up to 350 C, and it works in an open environment, open chamber. So these are typically glass-filled pellet materials, or mixing with the glass-filled, carbon fiber-filled, or some kind of reinforced material to keep their shape. I think this medium format space, we've got CAD, we've got Poly Products, we've got other companies operating in the space, and now we're seeing them do very specialized things. But we did see also like companies like Cincinnati come into the space with printers. We saw a lot of interest in things like boat hulls, large scale tooling for aerospace. And a lot of specialized applications, a lot of things that maybe aren't really well known. Like we had one point somebody from Poly Products on the Michiel Bruiker on the 3D pod, and he was talking about making like pools or jacuzzis for super yachts. Like this is a low volume application, but again, it's a specialized shape. It needs to be lightweight, or it needs to be made in a certain way. So I think we don't have all the applications that we could do with these technologies. We don't have them all mapped out yet. And I think there could be a lot more can become available. We saw swimming pools a few months ago. We still aren't clear if people are actually 3D printing and use swimming pools or the molds for them. But still, there's a lot more possible with these kind of medium format, large format systems. The next news is that IKDM 3D and 6K have started a partnership to make materials together or to make materials available. 6K Additive is a part of 6K that uses a uni-melt plasma microwave powder production process. What people may not realize is that if we're looking at the energy cost of 3D printing, everybody reflexively always says that the 3D printing is more energy efficient or more environmentally friendly. But we have to take we have to take material which is in billet form or rod form or something, and we turn it into powder. And that process in and of itself takes a lot of energy. And 6K says itself that it has a 91% reduction of energy use and 91% reduction, over 91% reduction in emissions use, compared to other traditional kind of gas atomization and prep and other types of processes to make powder. We need very specific size and specific morphology powder for 3D printing, and cost of that powder is quite considerable in terms of energy, environmental cost, but also just in terms of money. What IKDM is doing, IKDM, sorry, is doing. IKDM is a service bureau. They're ITAR, AS 9100D kind of approved or qualified service bureau that make a lot of military, a lot of aerospace components, a lot of really high-end stuff. And they're really looking to secure their powder supply. And working with 6K and their melt process means that they can get a domestic powder supply. They can go to their military customers and say, we're making this material in the United States of America. And what's more, it can make it from recycled powder. So it can take its support structures or degraded powder and then make new powder out of it. So environmentally, this is good news. This is also good news, I think, for IKDM. And as part of this release, they mentioned that, why do they partner with this continuous high-frequency microwave process that is able to produce powder? And what's the logic behind it? Well, one of the things driving their adoption of powder, their own powder, is just that they're saying that they're talking to customers that want really have applications that have, like, for example, 10 tons of metal powder per month. That's an incredible amount of parts that you would need to make if you were going to use 10 tons of metal powder a month. That's like way beyond the scale of nearly all producers in additive. To look at that as IKDM as in looking at these kinds of applications, then of course it would make a lot of logical sense for you to make your own powder, or to at least move yourself a little bit to a cheaper territory than before. The number 2 news is rockets for transport. This is the most sci-fi thing I've read all maybe month. So this is Rocket Lab and Sierra Space, 2 startups that extensively use 3D printing. They're joining the U.S. Air Force's Rocket Cargo program. Now this is the idea of using, I completely did not know this until I read this article on 3dprint.com by Vanessa Listic. It's using suborbital space vehicles for ultra-fast transport of personnel and cargo. So this is part of kind of an alliance, and Blue Origin, SpaceX, and Virgin Orbit are already members of this alliance. And the idea is point-to-point transport of earthbound goods via rockets. And this is either via the rocket transporting the thing from one part of the world to the other, or, and it gets crazier, for transporting goods to a space station and then deploying them in the space station, and then at a later date, or as the space station continues to orbit, deploying the people where they need to go, which of course be a super rapid and incredibly expensive way to get people and goods at a certain location. This is being coordinated by the Department of Defense, specifically the Transportation Command called US Transcom. And they're looking at super fast cargo delivery on Earth to do this. Now, the idea, they want timely delivery of items. Now, this, of course, I think is very, very possible with this method. They also want cost-effective delivery of items. That, to me, is super not cost-effective. That's going to be much more difficult to achieve. Of logistics and personnel, right? So they want to actually, what the quote is, they want to bring about the projection of forces for immediate employment and agile transportation options to project and sustain combat forces in complex and contested environments. So the idea really is they want to insert certain troops in a certain area very, very quickly. Think of a special operator or something like that, a group of special operators, something like that. The other thing is sustainment of forces in a certain area. Now, this may seem kind of crazy given the high cost. Like to launch something into space right now, it costs around 10,000 a kilo or something, just to give you an idea. Um, but the U.S. military, in certain cases, is paying thousands of dollars per kilo to transport things. Part of this is the high cost of certain suppliers. The other part of this is that, well, think of the U.S. military as like UPS with guns. We've got one guy in a forward operating base in a contested area, a very, very dangerous place to be. There's about 6 people that are needed to protect his supplies and to get in the supplies that he needs. Right? So we're going to have to then, these 6 people, of course, all require housing. They require food. They require bases. They require then roads in between these bases to secure the supply and all this. So this structure is very vulnerable. And this means you need to put, like, especially if you actually want to have one combat troop in the country, you're going to have to put 6 other people at risk. They can be ambushed. They could be struck by a mortar or something like that. You're going to have to put those 6 people at risk in order to just get the supplies to the guy that needs it in the front line. So this is kind of strangely logical. It's very, very logical. It's like, and the idea is, of course, if you would then just have the forward operating base and be able to resupply that from space, then obviously you would have to resupply a lot less stuff, right? The U.S. military is also working at water capture, air water capture, to get water from moist environments. They're also working on a lot of unmanned vehicles. So think about how now drones, like airborne drones, can be operated from Texas while they operate all across the world. Well, we could already see that the logic is there for the United States of America to do this with a lot of ground vehicles as well. So maybe a base of the future doesn't really have that many guys in it, right? It's got a lot of automated weapon systems. It's got a lot of automated vehicles. And then, of course, this kind of thing increasingly would say, okay, wait, we don't have to put all these bases supporting bases. We can supply these guys from space. I still think it's they're going to have to get an awful lot of money to make this possible. But it's simply the most sci-fi thing I've heard recently. The number one 3D printing news comes as courtesy of HP, that at IMTS has launched the Metaljet S100. So they've made the Metaljet, that's their binder jetting solution, commercially available as of today. This means that, well, the fight for binder jet supremacy is holding up. So we've got Desktop Metal, obviously, has deployed a solution. We've got Digital Metal, which is now part of Markforged, another publicly traded company, that is also deploying a solution, and GE is working on one as well. And binder jet, again, is a technology that is the cheapest way to get metal is either to cast it from a stereolithography part or to use a bound metal. So you use a material extrusion, a regular kind of Ultimaker type 3D printer, and then you then sinter this part, or debind and sinter this part. That's the cheapest way to get a metal part, essentially. Next up, you have like slurry SLA, which uses a casting in combination with a metallized photopolymer to do exactly the same thing. Then we have binder jet, which can produce a little bit bigger parts and at much lower cost. Binder jet has much lower cost than powder bed fusion because binder jet requires just regular MIM powders that are used for metal injection molding. So the powders have to be much less precise than the ones that the guys at 6K we talked about earlier are trying to create. And these powders have recreated them for powder bed fusion. So powder bed fusion gets you bigger parts, more accurate parts, typically more fine mechanical parts, but much, much more expensive. Think binder jet is like $2, let's say, or maybe $20, and powder bed fusion for the same part would be $200, let's say. So powder bed fusion is usually considered more accurate, but much more expensive. And above that, we have WAM, another technology, DED technologies, that create parts much less accurately, but also it's quite cheaper. And then we can make things up to 1 to 5 meters or something like that. But it's not greatly accurate. So binder jet has this really beautiful kind of space to be, right? Where slurry SLA, like the companies like MetShape, Litos is doing it for ceramics, Incas 3D is doing it for metals. These guys, and Hollow AM, these guys have really good, fine, really small parts. And binder jet is kind of like, well, let's say kind of like a few centimeters to 10 to let's say 10 by 10 by 10 centimeters industrial parts for low cost. So doing this, the space of the number of parts they can create is enormous, right? So the market is very exciting. Now, what HP is saying that its unique offering is that they have a thermal inkjet. That's HP's inkjet technology they use for whatever. If you've got a desk jet or something, the office, they'll use that. They say it has higher print speed, always good. Higher part quality and reliability, repeatability, also great. But the other thing that the company is saying, they have advanced latex chemistries, which make the binder better and make for stronger green parts. So, okay, binder jet. What are we doing? We take a powder, pretty much bog standard powder, and we take an inkjet to harden it. Then we have to depowder it, debind it, uh, and then we have a kind of really fragile, kind of held together kind of part that needs to go into an oven. Now, one of the biggest problems we have with binder jet is that these parts collapse under their own weight. So think of printing something like a wine glass. It's going to fall over on its stem, right? Um, or like a shape, like a kind of inverted pyramid kind of shape, it's going to like come apart at one point. It's just going to collapse on its own weight before we manage to get it in the oven. So the limitations of binder jet are part size. Um, it's really difficult to get a part right the first time because the wall thickness and the part geometry change the shrinkage rates, right? And then also what the other difficulty is that we have is that, well, there's multiple process steps, right? And there's collapsing into the green state thing. So if HP, it doesn't have to make the world better for a lot of people here. There could be a lot of customers out there that can't, with other binder jet systems, make the parts they want to make because the overhangs are too much, or the parts are too kind of colossal-ish, or have too much kind of sprues and things sticking out the side of them. So that could already be a wonderful niche for me for HP to conquer. The other thing is that they eliminating through their chemistry, they're eliminating the debinding step, right? Um, which I think is super exciting because that means that they're cutting a process step. Now, the one thing that I'm the most actually excited about HP in this respect is if we look at this in front of us right now, we have a industrialized solution. So what HP is doing is not just pitching a machine saying, "Hey, we've got this machine, go for it," right? So no, they're saying we've got a powder management station, which is the tall thing on the left with the stuff next to it, right? Then we've got a 3D printer, which is the thing in the middle. Then we've got a curing station, which is the thing to the right of that. And then the extreme right was we have a powder removal station. So this gives a company confidence to say, look, we're going to call HP, and there are one number. If something goes wrong with sintering, if something goes wrong with a process step, we could just get one solution from one company. I could really imagine that people are trying to leapfrog other people in additive. This is really very exciting, very tempting. A lot of the other vendors, you buy the machine from them, you have to cobble together your own oven and your own other kind of part from other people. So having so many things working in concert and coming out with this complete solution now, I think would be a really good advantage. Um, HP's worked so far with GKN, Cobra Golf, Schneider Electric, and Volkswagen, Doman, which is one of my favorite startups in 3D printing and making actuators and other things with 3D printers. And they also work with Legger Group, which is big, well, niche for us, I guess, but it's a big plating and alloys company, and Parmatech, which is a big MIM provider, to give them, I guess, a lot of expertise in where they want to go. They've got some nice, nifty examples. This is a GKN made Schneider Electric circuit breaker filter. You know, I think this is exciting. I think it's exciting I really think the binder jet could really could push us into new territory in industrial. I think it's the best solution if you want to if you want to qualify 1,000 parts in a repeatable, reliable, and cheap way, produce those parts worldwide on lots of different machines in lots of different locations. I think it's a fantastic way to do it. And I think that scope and the market could be quite considerable. So I think this is a great move. I think it's wonderful that we have more competitiveness in binder jet, more money being thrown at binder jet. Again, I don't really think this is a be-all, end-all technology because I really think that every single technology is going to be used extensively in its own like technology silo. So thank you very much. That was the news for today, and I really hope you enjoyed it. And